Hey guys, welcome back to another video, and today we'll be covering one of the well-known data structures of any programming language, which is linked list. So the concept of linked list comes from arrays, where like in arrays we have that concept of indexing and putting values inside of it, but where linked lists they come in is basically they try to solve the few problems that arrays have, like the fixed capacity problem, where we cannot, like when we have like more values than the capacity of that corresponding array. So this array, let's say, has a size of 2, and suddenly we have another value, let's say we want to put the value 3 here, but this is already occupied, so we have to create another array that has a length of 3, then we can put this value here. So this is very like not feasible, right? So you cannot increase the size of that array, where linked list has that concept where you can put any values inside and the size would dynamically increase, right? So what is this linked list? So from the book we can see that it says, which is a sequence of nodes connected by links. The links allow the inserting of new nodes anywhere in the list, or to remove an existing node from the list without having to disturb the rest of the list. So to better understand linked lists, we can use this concept, which is, let's say, chains, right? So linked list is basically the concept of chains come into play, where let's say this is a box, and this box is connected to another box, and that box is connected to another box, and inside these boxes or blocks you have some value. So let's say we have some balls here, and these blocks, they are connected to one another, and let's say you have another new box where you have another new ball, and you want to add this to that chain. So what you do, you just extend that last box or last box and connect it to this new block of yours, right? So this makes the chain larger, right? You do not have to resize the chain, or the concept is just isn't here of that, like the thing that you used to, the concept isn't here, right? So the thing that we had in arrays where we had to resize to make space for a new value, here we just add that corresponding block and connect it to the previous block. So this is where the concept of linked lists come into play. So linked lists have addressed these problems, so fixed capacity and shifting elements in insert and remove. So if we look into the things that we learned previously, is that whenever, like in a circular array, whenever we have a new value, let's say it starts from here 2 3 4 6, and you want to insert something in between 4 and 6, right? So the concept here is that you either shift 4 to the left, making it either 2 3 4 6, and you have this new space for a new value, or you do it like this, where you have 6, you have another value 4 here, and 6 basically shifts to the right, so 2 3, and making space for a new variable. So this is like a very troublesome process, right? Shifting values and checking if that space is already available or not. And when it comes to circular arrays, we have to check, we have to have the index number has to be checked if it goes at the last, and we have to traverse back to the front again. A lot of things that we have to keep in mind when doing all of this, right? However, in linked list, this isn't the case, where let's say you have this chain, say we numbered them 1 2 3. Let's say you want to put a new block in between 2 and 3, right? So this is, let's say, 2.5, right? You want to put this in between. In arrays we would have to do all the shifting and rotating and stuff, but in linked list what we do is we connect this. So we connect the box number 2 with 2.5 and connect 2.5 with 3, and this is like your new chain, right? It's much more easier to work with in linked list than compared to arrays. So how do you create this linked list that we are talking about? So remember, we have the concept of classes and objects in Java. So in a class, we have these attributes on these functions and stuff, and we create objects of these classes. But here, like in nodes creating, so what are these nodes? So as I said before, so these blocks, they're connected to one another, and these blocks, these are basically called nodes. And the blocks that I was talking about, the blocks, they had a ball or something that you want to put inside of it, right? That's where that's the main point of having all of this. So you want to put something inside of that block. So in actual terms, it's called a node. So it's not called a block, it's called a node. And inside of that node, you would have two things, or two or three things, depending on the type of linked list. So in a single linked list, or called a singly linked list, you would have two things. So what are these? The first thing is that item that you want to put into it. So it can be any element, it can be an integer, an object, or anything that you prefer. And the second thing is the link. So the boxes, they are connected to one another, right? So this box knows the address of the second box, and the second box knows the address of the third box. This is how they are connected to one another. So the second thing is the reference to the next node. So see, things are coming up together, right? So the nodes, they contain the elements, and the nodes, they have a reference to the next node. This is how they're connected to one another. So let's see the creation of these nodes. So we have a class which is called a node, and this class would have an attribute called an element, which you can put whatever you want. We are putting objects here, and you have the reference to another node, right? So the variable is called next, it holds a reference to another node. So this is how you create nodes. And if we look into it, we create an object node, let's say node n equals to new node, and this node, we have to pass parameters, right? So we whenever we are creating this n node or this n block, it has to have an element, it has to have a connection to something, right? So that's why we have to pass parameters. And how do we do that? Whenever we are creating an object, we have constructors. So this is what we are dealing with here. So the node class would have a constructor called the same name as the class, and it would pass in two things, right? The object, that thing that you want to put inside of that block, put inside of your node, and the reference to the next node. So we are passing two things here, so 1 and 2, right? And then we are assigning values to it. Similar concepts of classes and objects. If you are confused about classes and objects, you can look into other videos that I have in my channel. So initially, this node, that the first one that you created, generally is called the head of the node. So of the linked list, this is called the head, meaning this is the starting point. And that head, that has two things, right? It's element and the reference to the next node. And initially, when you create the head, it may contain the value. If you put it into it, it may contain the value, and it may contain the reference, however, to the next object. However, you might not have that reference here. So what you can do is that this node might not point to anything else. This itself is that linked list. Itself is the linked list, contains one block, one node, and that one node has one element. So for referencing portion of that, we put null, meaning that this is only one node and this doesn't point to anything else, but it can still have an element. Okay, so all of this is done. So everything looks good. We can replace an array now with a linked list, and we know what's inside of these nodes, how these nodes are connected to one another. Now what I said before, right? So this takes away the concept of directly going into any index and taking that value, right? You cannot directly go to index number 2 and get that value. We have to traverse the whole thing. So if we have this linked list here, let's number their positions 1, 2, 3 and 4, right? And you want to get the value that's inside of that third node. In arrays, you directly go, let's say you directly say array index 3 and get that value, right? But in linked list you can't do that. You have to start with the head, and that head would refer to another node and that another node and so on, until you reach the point where you have come to the third node and you get that value for that node, and then you print it out and do whatever you want with it. So this takes away that easiness or the convenience of getting directly a value, right? In arrays, the finding of a value is basically the time complexity is 1, whereas in linked list the worst case would be n, because the value that you're looking for or the index that you're wanting could be at the very end, and it might take you n traversals to actually reach to that end node of yours. However, the easiness of putting values inside is much convenient, so it depends what you actually need whenever you are creating any programs. So how do we traverse this linked list? So in arrays we had like while loops and for loops and stuff. So linked list actually follows all of this. So you can have a while loop where you have, let's say, your node n, and that node n starts at the head, and you traverse until n is not equal to null, and for the increments you do is n equals to n dot next. So let's just try to see what's happening here. So this is your head, right? So your n points here at the head, and the loop would continue until n not equals to null. So is n null? No, n represents something, a node, and you traverse, so you go to the next one, so n becomes this one right now. And is this one a null? So does n represent something null? No, it doesn't. It represents a node. Then you go again, so you n dot next, and thus this represents n now. Similarly, you check again, is n referring to something null? No, it's referring to n node. You traverse again, you do n dot next. Now this next, this is the last node, right? And this last node may have an element, and for the reference it doesn't have anything. It's basically null. It's pointing to nothing. So this next, so n dot next would give null, and this null would be put into n. Now whenever we enter into the condition, so is n not equal to null, this doesn't satisfy anymore, so we do not go into that into the loop again. And if you're still confused about where this next comes in, this is from here, where we had another variable for the class node next, where next represents the reference to the next node. So when next at some point would be null, right? It doesn't have any something, it doesn't have something to refer to next. That's why it becomes null, and we get out of that loop. So this is how you traverse linked list. So let's try to look into an example through like the iterations of a linked list. So let's say you are asked to count the numbers of elements in a list. So what do we do? Like in normal arrays, we basically do a for loop or a while loop, and we traverse the whole array, and we increase the count by 1, right? And this is similar in linked list, because we do the same thing. We do the while loop or whatever we prefer, and while n not equals to null, we do count plus plus, and n equals to n dot next. So this is how we will be counting the number of elements that we have in that linked list. That's pretty easy, and this is how you do with using for loops. So we start with the head, we go until n becomes null, and we do the iteration where n equals to n dot next, and we do count plus plus. So that is it for today's video. Hope you guys did enjoy it. We would be covering more linked lists in the upcoming parts of linked lists. Thank you.